Hello learners, and welcome to today's lesson on the volume of 3D objects, where today we are going to be focusing on the practice and application questions. So let's get down to our questions. So we are going to start off with some practice questions. The first one there says, calculate the volume of this cube with a length of 5 centimeters. So remember, a cube has all the surfaces as squares, and in a square, all the lengths are equal, which means if we have been given one length of 5 centimeters, that means that also the height is 5 centimeters, the length is 5 centimeters, and the breadth is 5 centimeters. Now, do you remember what is the formula for the volume of a cube? Now, the volume of a cube will have the formula of the length cubed. Why is it the length cubed? Because it is the length multiplied by the breadth multiplied by the height. And because this is the same value, it means that we are multiplying a value by itself twice, which is cubing that value. So the volume of this cube is going to be 5 centimeters cubed. And when we take 5 centimeters and we cube it, it is going to give us an answer of 125 centimeters cubed. And that is now the volume of that cube. Let's move over to our next question. Now, the next question here says, calculate the volume of the object below. So as we can see, the object below there is a triangular prism. And how do we see that? It's because that the top and the bottom, or the base and the top, are triangles. And these, of course, are right angle triangles. So what are we going to need to calculate the volume of this object? We are, of course, going to need the the area of the base, which in this case is the triangle, and then we are going to multiply that with the height of the prism. So we already have the height, which is our 10 meters there. But when we look at the base, we have a right angle triangle where we do have the base, but we do not have the height. So how are we going to calculate that height? Now, because this is a right angle triangle, then that means that we are going to calculate the missing height using Pythagoras. Remember, Pythagoras only needs us to have 2 of the sides, and then we can calculate the third side. And when we are looking at that triangle there, we do have that 13 meters there, because remember, the top and the bottom of our prism, they are parallel and they are congruent as well, which means that the 13 meters that we've been given there also applies to the other triangle, which is the 13 meters. And of course, we have that base there. So let's calculate this missing height. Remember, Pythagoras says there that the hypotenuse squared will be equals to one side squared, and in this case 5 meters squared, plus another side squared. Because we don't know what that side is, we can use a variable to represent that side. So we can just use a y, and of course we know that that value is going to be squared. So 13 meters squared will give us 169 meters squared, and then 5 meters squared will give us 25 meters squared plus our y squared. Of course, for us to be able to work out what our unknown value is, we are going to subtract by 25 meters squared on both sides. This means that this side we are going to say 169 meters squared minus 25 meters squared. When we subtract 25 meters squared on the right hand side, then we are going to be left with only the unknown value squared. Then that means that we are going to have now 169 meters squared minus 25 meters squared will leave us with 144 meters squared. And of course, for us to work out our unknown value, we are going to square root both sides. Now, the square root of 144 meters squared, remember, can either be a positive or a negative 12 meters squared. That means that the unknown value is a positive or a negative 12 meters. Sorry, not meters squared, but meters. But how do we decide which one we take between the positive one and the negative one? Well, we are working with distance, and now our distance cannot be negative, it can be positive. So that is going to be, that means that our unknown value is going to be 12 meters there. So that means that our height there is 12 meters. And now that we have the height of the triangle, that means we can calculate the volume of our prism. So remember, the volume of a triangular prism will be now let me write it down here since we have more space there. So the volume of a triangular prism will be the 1/2 multiplied by the base multiplied by the height. And we are going to multiply this by the height of the prism. So the volume of this triangular prism is going to be 1/2 multiplied by 5 meters, which is the base of our triangle, multiplied by 12 meters, which is the height of our triangle. And lastly, we are going to multiply this by the height of the prism, which is going to be the 10 meters. So that brings the volume of our triangular prism to, remember, we are going to say 1/2 multiplied by the 5 meters multiplied by the 12 meters. And that answer we are going to multiply by the 10 meters. That is going to give us a volume of 300 meters cubed. And that is going to be our final answer for the volume of that prism. Let's move over to the next question. We have now here been given a cylinder. So it says there, calculate the volume of the following cylinder with a diameter of 16 meters, actually, and not centimeters. So 16 meters and a height of 20 meters as shown in our diagram. So we have 16 meters and 20 meters as our values. Remember, for us to calculate the volume of a cylinder, we need the radius and the height of that cylinder. Now, we have been given a diameter of 16 meters. And if we remember correctly, the diameter is double of the radius. That means that if we want the radius from the diameter, we need to cut our diameter in half, or we need to divide our diameter by 2. So that means that the radius there is going to be 8 meters. So what is the formula for the volume of a cylinder again? The volume of a cylinder is going to be our pi multiplied by our r squared multiplied by our height. So when we substitute the values there, remember pi is 3,14. We are going to multiply this by our radius, which is our 8 meters squared. We're going to square that radius, and then we're going to multiply that by our height, which is 20 meters. So what is 3,14 multiplied by 8 meters squared multiplied by our 20 meters? That is going to give us an answer of 4,019,2 meters cubed. And of course, our answer is cubed because there we have a meter squared, and when we multiply that by meters, that gives us a meters cubed. Let's look at our fourth question there, and it says there, calculate the volume of the following figure with a height of 10 centimeters, a length of 7 centimeters, and a breadth of 2 centimeters. Now, if we look at this figure that we have been given, it is indeed a rectangular prism. So if you saw that, that means already you have in mind what the formula for the volume of a rectangular prism must be. So that formula for the rectangular prism is going to be our length multiplied by our breadth, and we are going to multiply that by our height. So the length in this case we have been given as 7 centimeters. We're going to multiply this by the breadth, which is 2 centimeters. And lastly, we are going to multiply this by the height, which was given as 10 centimeters. So 7 centimeters multiplied by 2 centimeters multiplied by 10 centimeters is going to give us an answer of 140 centimeters cubed. And that, of course, is the volume of that rectangular prism. Let's go to an ad break, and then we'll see you just now for the rest of our lesson.